Hello, my dear students, and welcome to today's class. As you can see on your screens, the chapter is Lightning and Earthquake. Okay, so let's start the chapter. We start with electric charges. Okay, children, you must have at many times taken a comb and rub against your hair. And after rubbing that, if you take small pieces of paper and bring in contact with it, what happens? The small bits of paper, they stick to your comb. Why has it happened? It has happened because the pieces of paper, they attracted towards the comb due to electric charge. Okay, so I'm going to start the chapter with electric charge. So let's start the chapter. As you can see on your screens also, children. Fine. Okay. Electric charge, as I told you, when you're rubbing the comb, okay, against your hair and then bringing the comb back in contact with the small pieces of paper that you have torn. And what is happening? The papers, they're getting attached, they're getting attracted towards the comb. That is electric charge. Now, if I talk about electric charges, there are two types of electric charges, children. One is positive and the other one is negative. Okay. It is of two types, positive and negative. The positively charged particles in an atom are called protons, whereas the negatively charged particles are known as electrons. Okay, that negatively charged particles in an atom are called electrons. Okay, in case if two materials which have the same charge are brought too close to each other, they will repel. Okay, opposite charges they repel, same charges they repel, but the opposite charges, what happens? They attract each other. Okay, hence positive and positive or negative will always repel. As I told you, same charges will repel. Whereas on the other hand, if the charges are of different charges, okay, one is positive or other one is negative, or the first one is negative and the other one is positive, then what will happen? They will attract each other. Okay, now here you can see, unlike charges, that is positive, negative, always attract each other. An atom will be considered neutral if it contains equal amount of positive and negative charges. In case the atom has equal number of positive, that is protons, and negative charge, that is electrons, then what will happen? The atom would be neutral charge. Okay, in case protons are more, it would be positively charged. In case the electrons are more, then the atom would be negatively charged. Fine. Now moving to the next one. There are different ways of charging an object. Okay, first one is charging by friction. Okay, there are three different ways. First is charging by friction. Okay, so we'll start. This kind of charging results when material is rubbed against another material. Have you ever rubbed a rubber ball against your hair? When done, you will notice a force of attraction between your hair and the rubber ball. This phenomena can be explained with the help of the following activities. Just you can go through them. In case the two materials are rubbed against each other, the friction force would be there, and due to which the charged material gets electrically charged. Okay, you can just go through this activity. There is nothing much in it to explain. Okay, just read it. Now, the next one is charging by conduction. Earlier I told you about friction, now charging by conduction. What happens in charging by conduction? Conduction is the process in which an electrically charged body is used to charge a neutral body by making a contact. Both the bodies come in contact with each other. That is charging by conduction. But if I talk about charging by conduction, what will happen? Induction. The bodies, they do not physically touch. Okay, they do not come physically in contact with each other. Induction charging is a method used to charge an object without touching the neutral object to be charged. Okay, you don't touch both the objects, they don't come in contact with each other. But in conduction, both the objects, they come in contact. Physical contact is there, but in induction, no physical contact is there. Fine. Now, we'll move to the next one. Electroscope and transfer of charge. You can see on your screen also. Okay, I'll tell you what an electroscope is then. How does it work now? Okay, An electroscope is a device that is used to detect charges, whether the charge is positive or whether the charge is negative. You can detect with the help of a electroscope. Okay, it consists of two thin metal strips, most of gold, also called as gold leaf. The leaves are connected to the knob through a metal rod. Now, see, what is this? You can see over here. This is a electroscope. This is an electroscope. And what is there in the electroscope? It is a device used to detect charges. And what is there? It has two thin metals. Okay, na? Two thin metals are there, and one of the strip is of most of the strips, they are made up of gold. Okay, and the leaves are connected to the knob. You can see the leaves are connected to the knob. Okay, now working of an electroscope. When a knob is touched with a charged object, the metal leaves spread apart. This is because the charge from the object is conducted from the metal rod to the leaf. Since they are receiving the same type of charges, they repel each other. As I told you, whenever the charges would be same, what will happen? It will repel. So when this the knob was touched, what happened? The leaves got repelled. Why? Because the same charges were there. And in case the leaf joins together, then that means the charges are of opposite side. Okay. Now, moving to the next one. Okay. You can see on your screens here. Okay, it is clearly visible now. We have learned that when a charged body encounters an uncharged body, electric charge is transferred from the charged body to the uncharged body till the charges on both sides become equal. What happens? The particles are flown from the charged one to the uncharged one. And till what time they will flow? Till the time they are in balance. They are equal. Okay. Till the time both the bodies, they become equally charged, it will keep on flowing. Okay. This process is called discharging. When the body comes in contact with the earth, the charges are discharged to the earth, and this is called grounding or earthing. Okay. I hope I am clear. Now we'll start with lightning. What is lightning? When it rains, you must have seen lightning is there in the sky. I'm talking about the same lightning. Okay. Lightning is a phenomena in which there is a massive discharge of electrostatic charge between electrically charged clouds or between the clouds and the surface of the earth. Okay. The clouds, they are charged. Okay. Whenever they meet, okay, what happens? The lightning can be seen. Okay. How lightning occurs now? Here you can see. I'm going to read out for you. Okay. When the thunderstorm develop, the air current moves upward and the water droplets move downward. What is happening? Whenever the thunderstorm is there, the air current, it starts moving upward. It starts moving upward and the water droplets start moving downward. Current is moving up and the water droplets, they are moving down. Whenever the rain is there, it rains down now. So, what is happening? The current is moving up and the water is falling down. Okay. This movement of thunderstorm and water droplets cause separation of charges. Whenever this is happening, what happens? The charges, they get separated. The reason behind this concept is still not understood by the scientist. Okay. So, in this process, the positive charge collects at the upper edge of the cloud, while the negative charges collect at the lower edge of the cloud. Upper side, what will happen? The positive would collect, and at the down part, what will collect? The negatively charged particles would collect. Okay. There is accumulation of positive charge at the ground also. It is considered that air is a poor conductor of electricity, but when the charge accumulates in large amount, the air becomes unable to resist the flow of the charge. This causes melting of positive and negative charges, producing streaks of bright light and sound. And this process is known as lightning. Fine, children? I hope I am clear. Now moving to the next topic. What measures should be taken while it is lightning? जब बाहर बारिश हो रही है बहुत ज़्यादा और lightning हो रही है, हमें क्या precautions लेने चाहिए? That I'm going to read out for you. Okay. First, Whenever you hear a thunderstorm, always rush to a safer place. Don't stand down. Okay, don't move out and keep on staring. Okay, in fact, you should rush to a safer place. Don't forget to close the doors and windows of your vehicle or house. Don't try to opt for a shelter that have no roofs. You should be always under a roof. Okay, children? Then, if you are in a forest, rush to take shelter under shorter trees instead of tall trees. Okay? Don't go and stand under the tall tree. In fact, take a shelter where the trees are short. Okay? If you have been stuck in an open field where there is no safer place to hide, squat low on the ground. Place your hands on your ears and your head should be resting between your hands. Fine? Do not lie on the ground. Letna nahi hai. What you are going to do? You are going to sit. Okay? Fine, children? Then stay away from metal objects like electric poles. Okay, what is happening? Because lightning is there, the charges are flowing. In case you would be standing near the electric poles, maybe the electric current passes through the electric pole and you get a shock. Fine. Now, safety measures to be followed during a thunderstorm. Okay. Safety measures to be followed at home during a thunderstorm. First one, since lightning is electric discharge, it can strike electric cords and wirings. Example, telephone wiring. Don't use telephones that are connected to electric wirings. You can use cordless mobile phones or mobile phones. Then don't use electrical appliances like computers, television, washing machine. Don't take bath during thunderstorm as tap water is a good conductor of electricity. As I told you, if you remember, tap water, it has a lot of minerals. So when the minerals are there, then it becomes a good conductor of electricity. Okay. So don't take a bath during that time. Fine. Then lightning conductor. Next topic is lightning conductor. You can see on your screens here. Okay. It is a device that is used to protect building from the effect of lightning. It consists of a metallic rod which is taller than the building. One end of the rod is deep buried in the earth and the other is kept out in the air. You can see over here. See, the rod is there. The upper part, it's in the air and the lower part, it's deep buried in the earth. Okay. This metallic rod is installed in the walls of the building during its construction. This conductor has to provide easy path for lighting to enter the ground without affecting the building. Fine, children? These days, when the art engineers and all, they're making the big buildings, they take care of it, that proper lightning conductors are there. Okay? Fine. Now, moving to the next one. The next topic is earthquakes. What is an earthquake? The sudden shake. Whenever there is a sudden shake in the earth crust, that is known as earthquake. Children, it can be very dangerous if it is of high magnitude. Okay. So, now, what is earthquake? The shaking of the ground caused by sudden movement in the earth's process called an earthquake. Okay. It is a natural phenomenon in which the tectonic plates under the surface of the earth slide past each other, causing tremors on the surface of the earth. And whenever the earthquake is there, a huge loss of both life and property is there. Fine. Now we'll talk about the structure of the earth. The earth consists of the following three major layers. First is crust, mantle and core. As you can see in this diagram also is there. First is inner core, outer core, mantle and crust. Okay. Core is further divided into two types, outer and inner. Okay. The mantles consist of semi-solid material. The crust lies above the mantle. It's very easy. You can just go through it. Okay. And here it is given. The regions where one tectonic plate slides over other is referred as faulty zones. Okay. Wherever the tectonic plates they are moving, that area will be more prone to earthquake. Okay. And those zones are known as faulty zones. These zones are the regions where earthquake is likely to occur. They are also referred to as seismic zones. And the instrument used to measure seismic wave is called seismograph. Fine? And people who study the behavior of earthquake are called seismologists. Okay? Seismologists. Okay, fine, children. Now we'll talk about plate tectonics. Okay? Here you can see on your screens also. Okay. The lithosphere of the earth has fractures on it. It is not a solid continuous mass of land or shell. These fractures divide the lithosphere into smaller masses called plates. Children, the earth crust, as we go deep in the earth, what is happening? First, all the rocks would be there, then semi solid would be there. Then at the time when we are inside the earth crust very deep, what is there? Everything is in molten state because due to friction, lot of heat is produced, and when heat is produced, whatever is there, it melts down. If you rub your hand for some time, you can see lot of heat is produced and you will feel warm. So think about the earth which is rotating from a very long time. How much heat is there and what is happening inside the earth? All the rocks, they're getting melted due to this heat. Okay. Now, how an earthquake occurs? How does an earthquake occurs? The plate slide past each other. As they move, they get locked to each other, building more pressure between two plates. The edges of the plates give in and the plate suddenly moves with a jolt. The edges of the plates where the plates give in called the focus. The point on the surface of the earth directly above the focus is called the epicenter. Here, wherever the epicenter of the earthquake is there, lot of loss of property and life is there. Okay. The vibrations or tremors caused by an earthquake travel in the form of waves along the surface of the earth, and these waves are called seismic waves. Fine, children? Now, I'll tell you about the instrument which we use to measure this. So, that is called seismograph. Okay? The instrument used to measure the earthquake wave is called a seismograph. Fine, children? And the power of an earthquake is expressed in terms of magnitude on a scale called Richter scale. And the Richter scale ranges from 2 to 9, with 9 indicating highest intensity. Okay? When the Richter scale, it is divided from 2 to 9. Okay? Whenever it is of 2 to 4, it is a mild one. 4 to 8, it is moderate to severe. And 8 to 9, it is a highly severe one. Okay? Hazards of earthquake now. Okay, what are the hazards? What happens after the earthquake now? Damage to buildings and roads, breakdown of electric power or gas lines. Earthquake can cause rupture in dams. Dams are there. You know what are dams? Dams are the places where a lot of water is saved and electricity is made. What happens? They get cracked. Okay. Buildings can even sink in the ground if soil liquefaction occurs. Okay. Protection against earthquake. How can we protect ourselves against this earthquake? Okay. People living in seismic zones should take necessary precaution. They should take care that the houses in which they are living should be designed in such a way that they can withstand major tremors. Okay. The material made for making buildings should be of mud or timber and not heavy material, because whenever the earthquake is there, the building collapses and the material is there. In case it is going to be heavy one, what will happen? We will hurt ourselves very seriously. In case it is made of mud or bricks, what will happen? The house will collapse, but we will not get so much hurt. Okay. Cupboards should be fixed in the walls. Keep fire fighting equipments at places which are easy to approach. Okay. Now, with this we end the chapter.